participative. So you have to keep on answering me on the chat box. Okay, so right now let us start with today's topic. So guys, shall we start with today's topic? Can you please give me a quick confirmation? Okay, perfect guys, perfect. So right now I'll be starting with the today's topic, which is simple linear regression. So guys, what do we mean by simple linear regression? It is something which is related to prediction, and the prediction is based on some past or the historical data. So what do I mean by historical data? Let's say I got number of years of experience of an employee, and with the experience the salary will increase. Now let's say if I have an experience of somewhat of an employee of, let's say, 10 years, so what will be the predicted salary in 12 years? So this kind of data is this could be one of the data that could be based on the simple linear regression. So what do I mean by like regression? Regression is specifically used for, you can say, prediction. So regression is specifically used for prediction. So we will be predicting the salary, right, which is based on the historical data, right? So I'll be just starting with a quick walkthrough. What is simple linear regression? So like, how many of you remember the linear equation line, or I can say y is equal to mx plus c, guys? Do you remember the line equation of a line, linear line? If I write it like this, so this is something like y is equal to mx plus c. All of you remember? So what is m? M is can you tell me like what is an m? Guys, can you please give me a quick confirmation? M is the slope. Correct, perfect. C is the y-intercept, isn't it? Right? And you can say x is my independent variable, and whereas my y is my dependent variable, right? X is my independent variable and y is my dependent variable. This we have discussed in the previous session. Now let us extrapolate this to this part. Now in the linear equation line, you will be writing this in this way: y is equal to b naught plus b1 times x1. Now x1 is my independent variable and y is my dependent variable. So based on my independent variable, you have to predict the value of y. So let's say for this, the salary would be you can say will be the predicted part. So it will be my dependent variable, and years of experience would be my independent variable. I hope this makes sense. And based on some data, I will be predicting the salary part. So like simple so there are so many kinds of different kind of linear regression as well. Like you got multiple linear regression, polynomial regression, logarithmic regression. So basically it varies from data to data. So over here in today's session, we will be generally be talking about a very simple data which is based on the simple linear regression. So I'll just show you the data first of all in the Colab. So this is the data which I've already you can say applied, or already I have just inserted in like Google Notebook. So you can see there are 30 fields, 30 entries, right? And you can see years of experience. And with the year, as we increase the years of experience, so the salary is getting increased, right? So this is the data that we will be working today. So this is the data that I'll also be sharing you on the group itself, salary underscore data dot csv. So like this is one of the file, guys. So I wish the data is clear to everyone. So we will be predicting afterwards entry. Okay, how do we import our data on the Colab? See, it's very simple. You see on this icon, there might be some data that might be stored in your computer. You just simply drag and drop over here. This is one option. Another option is just go to upload. A window will open. Just take any file and then do the uploading. I hope this is clear to you, Pragati. It's very simple. Pragati, it is clear. Okay, perfect. So you have to make yourself acquainted with the Google Colab. It's a really very handy tool. Now, guys, I'll just, so I hope all of you are clear what the data we talking about. And so we will be predicting the salary, which is based on the years of experience. So salary is my, you can say the dependent variable, and experience is my independent variable. Now, B1 is generally the slope. So it will tell me the tilting of the line. I hope all of you are clear with the slope, like what inclination it has towards the x-axis, right? How much line is inclined towards the x-axis will be determined by the B1. I hope this makes sense, guys. All of you are clear with the B1 part? B1 is generally, I'm just explaining that what is a B1? B1 is a slope. Just simply, we are just, this is resembling to this particular equation, right? I hope all of you are clear with this, guys. Please simply type yes or no. Okay, perfect, perfect. Now, B naught is my y-intercept. Sorry, B naught is my x-intercept when my x is 0. Okay. So what do I mean by like this B naught? B naught is generally the how much this particular variable. See, if you plug in experience as 0, so this particular thing will become 0. So y is equal to the B naught. So B naught can be my like the starting salary, right? From the of the equation where my this particular line will be starting. So I'll be just explaining what is this particular line, right? So I hope all of you are clear with the B naught. When experience is 0, what is the value of B? Y, right? I hope this makes sense. Guys, I hope this makes sense. Vaishnavi, please type your question in the chat box. Any query in the chat box. So guys, I'll also explain you like what do I mean by predicting the values. Like let's say if there is a 1 year increase in the experience, there will be some certain change in the like also in the salary. So corresponding to the change, you can see with 1 year increase in experience, there is a 10 plus increase in what? 10K increase in the salary. So you can extrapolate the thinking, right? So based on the change in experience, what is the change in salary? So on that grounds, you will be predicting. So I hope this makes sense. What is how why the slope is important? Guys, are we all clear with this? It is giving you one example only. Like, are we all clear with this? Can you please type yes or no so that I can move ahead with the the further explanation? Okay, perfect, guys, perfect. Now the thing is, I'll be just have a quick walkthrough to like what do we mean by what what is this kind of plot. So I'll just show you an example. So let us draw some axes, right? Now, see, now we are actually drawing the two fields. So which is, guys, you can say we are just drawing the two fields, which is based on the salary. You can say which is based on the salary, right? So let me draw some quick dot plots. Okay, I think there is some issue with this. Just give me a minute. Okay, I'll just explain you in different way. So guys, basically what I wanted to say, like this particular data, if you see in the collab, see if you do not work in the collab, so it will be reconnecting. So I'll just show you the data set first of all. Okay, okay. Actually, it has gone to the runtime, so I have to again like, okay, it worked. Okay, fine. Now the thing is, this particular thing, you can say the points over here are representing the salary. So this particular part, the salaries are 39343, 46205. So if you draw it on the scatter plot, let's say if you draw a plot which is based on the salary versus experience. So this particular plot is representing a salary corresponding to a specific experience. So these are the actual values, right? I hope all of you are getting what I am trying to say. So this kind of plot is termed as a scatter plot. Now, scatter plot is one of the most preferred, you can say, plotting of regression. It is highly used. I hope all of you are clear what I'm trying to say. Now, this particular dots are basically my actual salary, which is based on the corresponding experience. Guys, I hope this makes sense. I hope this is clear to everyone. Okay. Now, the thing is, this particular line, how I would know like this particular line, this particular line is termed as, there's a name for this. So this particular line is termed as line of best fit. So the line of best fit is actually predicting the values of subsequent experience. Let's say if I have a experience till over here, like, and let me extrapolate the experience till over here. What do I mean by extrapolation? Means increasing this line by some dotted lines. So based on that, there will be a corresponding salary. So this is my predicted salary. So this prediction is highly based on what? This particular line. So this particular line is called as line of best fit, which is the best indicator of the predicted values. I hope this is clear to everyone. What do I mean by line of best fit? So line of best fit, by extrapolating the line of best of fit, you will be knowing like what will be the salary in the future. So let's say you got an experience of 10 years. So you don't have data over here, right? So what you will be doing, you will be just extrapolating the line, and based on that, you can predict the corresponding salary. So this is how simple linear regression works. I hope this is clear to everyone. Can you please type yes and no? Okay, perfect, perfect, perfect. So I'm just going with the concept part first. So now, how do I know, guys? Like, what is my line? What is my like a good fit? Or you can say there might be possibility that my particular line of best fit lies somewhat parallel to this line, but slightly above or slightly below. So how would I know that my particular trend line or the line of best fit is the best indicator of the prediction? Are you getting my point, guys? There might be some possibility that my line of best fit can lie over this line or underneath this line, isn't it? So how would I know that whether this particular line is my line of best fit or not, right? So there is a method which is called as, I'll just write the method name, which is called as ordinary least square method. In some of the book, you will find OLSM. So this is a short name of this. So what is the method which is termed as ordinary least square method? This will tell you like which particular line of best fit is the best trend line, or you can say it is the line of best fit. Which particular line is best representing the line of best fit? I hope this is clear to everyone. What do I mean by ordinary least square method? So this will tell you like which particular line is going to be my line of best fit, because there can be infinite lines that you can draw within this particular data set, but that particular line should be the best representation of the data set which is presented as a scatter plot. I hope this is clear to everyone. Now there is a math behind this, so I'll just tell you the math. What is the math behind this, right? But first of all, are you clear what is ordinary least square method? So this is a method that will tell you which particular line of best, what is the best predicting line, or what is a line of best fit that fits the scatter plot appropriately, or the best, right? See, Pragati, you have to understand in this way. Uh, this particular scatter plot, when once you visualize that into the computer, it will create infinite line of best fit. But what particular line of best fit we should choose, this is totally based on ordinary least square method, right? So what is the ordinary least square method? This is based on this equation, which is sum of y minus y hat whole square, and that should be minimum. So like what is my yi and what is my yi hat, right? So basically my yi is the actual salary, right? Are you getting my point? Yi is my actual salary and my yi hat is the predicted salary, right? Similarly, there will be this from this, the deviation from the actual salary and the predicted salary. Similarly, the difference from the actual salary and the predicted salary. Similarly, underneath also. So it will take like all the, you can say the variables or the components which is lying above the line and below the line. After like all the y, all the predicted part, and sorry, all the y hat, all the, you can say the predicted part and the actual salary which is lying underneath and overneath of the line, right? If you take the difference and if you take the square, and if that square comes out to be the minimum, so that particular trend line will be the line of best fit. So intuitively you can understand in this way, the computer has drawn an infinite line across the scatter plot, and there it has found one line whose sum of the difference of the sum of the square, right, is minimum. Are you getting my point? So this particular, if it has find the minimum value of the sum of the square of the difference, then that particular line is called as line of best fit, and this method is called as ordinary least square method. I hope this is clear to everyone. Guys, can you give me a quick confirmation with a yes or no? Perfect, perfect. So you have to just understand it intuitively, like what is like happening with the ordinary least square. Computer is drawing infinite lines, and it is finding one line whose the difference of the sum of the square is the minimum, and yi cap is my predicted value, and yi is my actual value, right? I hope this is clear to everyone, guys. This is a intuitive. So we will be working on the data, right? The computer will do all the computation. You no need to worry, right? Okay, now let's move on. Are we okay? So let's move on to the data set. I've already imported the data. Now, guys, as I was mentioning previously, like we will be utilizing the data pre-processing template. Now, if you look into the data, there ain't any, you can say, missing field, as well as both the data are continuous. So I think I do not need to do any kind of missing value. replacement, and as well as one hat encoding is also not required because both the data are continuous. Are we all clear with this? Can you please type yes and no? Right. Perfect, guys. Now, guys, since I have already shared you the data pre-processing template, so this is one of the template that we have used in the previous session. So what I'll be doing, I'll be just copying this, the data pre-processing template. So this is a template which you can use to different data set in order to analyze the result. So like I'll be starting with importing the library, pressing Control plus Enter, so it executed properly. Then from the template, I'll be just importing the data set and the X and the Y variables, right? So from here, right, I'll be just, I'm just using the things from the template only so that you guys are efficient, right? So that you follow the standardized rule, right? Now you can see over here in the previous session, we use data.csv. Over here, we have the file which is salary underscore data.csv. So what I'll be doing, I'll just replace this name with, okay, I'll just replace this name with salary underscore data.csv. I hope this is clear to everyone. Can you please type yes and no? Okay. Now the thing is, let me run this. Okay, it executed properly. Now after this, we will be split the data into the training set and the test set. What we did in the previous session, similarly, we'll be doing that as well. Okay, I've already did this. Now over here, we will be splitting the data into the training set and the test set, just same as what we did in the previous session, right? So while splitting the data into the training set and the test set, you can take the test size to be anything. So let's say there are 30 fields, right? So let us do this time the test splitting. You can say, let us take the test size to be 10 fields and the training size to be 20 fields. So guys, can I do this modification? So for this, I'm just splitting the data into the training set. Okay, this is the template. Okay, let me copy this first. Since you can see over here, right, there are 30 fields. So what do I mean by 30 fields? That like you can see over here, there are 30 entries. So 1 by 3, the test size will give you how much of the data to the test. How many fields, guys? How many rows will be going to the test set? Can you please tell me how many rows will be going to the test size? 10. And for the training? For the training? Perfect, guys. Perfect. Perfect. So like, let me run this. Okay, so it executed properly. So we have splitted the data into the training set and the test set. Now our agenda is, this is one of the like the flow chart. So we till over here, we have already imported the libraries. We have already imported the data set. We have splitted the data into the training set and the test set. Now we will be training the simple linear regression model on the training set. So what we are just going to do, we are going to apply simple linear regression on the training set. Since I have already mentioned previously that the training from the training set, what we are generally going to do on the training set, we are just generally going to do the calculation. Now, when it comes to prediction, we will be going to the test set results. So I hope this makes sense. Guys, I hope this makes sense. Perfect, 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 guys. Okay, now let me close this for a while and let me close this. I'll just show you like there is a specific code for training the data from the like simple linear regression on the training set. So again, I'll be utilizing the library which is called as sklearn. So from sklearn dot linear underscore model. So linear model is one of the modules from the scikit-learn library, which have a functionality which is linear. You can see it is automatically predicting linear regression. Now I'll be utilizing. So guys, what happened like from the scikit-learn, I've just imported a module which is linear model and which has imported our library which is called as linear regression. So I'm just giving this linear regression a name such as regressor. So what it will do, like let me first of all give it a like the functionality. So you can already see that the Python is already getting it predicted. And regressor dot fit. So it follows two way. Like first of all, I've just doing the thing on the training data. So I have a training data and Y train data. So I'll be doing the fitting part because the training data is used for the calculation. So I'll be doing the fitting part. So fitting of what? The linear regression line in the training set and the test set. That will be my agenda, right? So guys, I'll be just fitting it on the training set. So X train, comma, Y underscore train. Okay, so it executed properly. So what the output is, it is showing that it has an intercept and the normalize. Okay, it do not do the normalized part because we have only the single cell. So normalization works really well when you got like more than 2 or 3 4 fields. And like you can also see that there is an intercept in the data. So this is one of the, you can say the basic step in doing the linear regression. One of the, you can say the subsequent step. I hope this is clear to everyone, like what is happening. Like we are only fitting the linear regression to the training set because the training set is used for the calculation. I hope this is clear to everyone. Can you give me a quick confirmation, guys? Okay, perfect. Guys, one thing, I'll be just resharing you the link again. I think the meeting time is going to be over. I think by mistakenly I've just set it for 40 minutes. So I'll be just resharing you the meeting after 2 minutes again. So please join it. Please rejoin it. Sorry for the inconvenience. Okay, fine. So before I'll be sharing you the meeting link again on the group itself. So guys, I'll be just predicting the test set result. I'll just show you a small block of code. So this is something like y underscore pred. So this is one variable which is I am just giving the name. So I'll be using the regressor. So regressor is generally used to predict. So predict means like while extrapolating the graph, right? So predict X test. See, the prediction will be how much good is my prediction or how much accurate is my model. So the total prediction will be based on the test set, and you can say the calculation will be based on the training set. So the prediction, the more the accurate is my prediction, so the more accuracy it will show on the test set. So that's why I've used YPRED as the test set. I hope this makes sense. Guys, can you give me a quick confirmation?